CBAF, the Continuous Electron Beam Accelerator Facility, is a new laboratory for basic nuclear physics research. At CBAF, scientists can advance our understanding of matter itself by probing the quarks and gluons in the atom's nucleus with beams of electrons from a superconducting accelerator. CBAF has an educational mission as well. The CBAF Science Series features scientists and engineers who are gifted at making their work not only informative, but fun. The Science Series is held once a month during the school year in the CBAF Center Auditorium. The presentation is live, spontaneous, and for the most part, unrehearsed.
Good evening. I'm Bev Hartline, CBAF Associate Director, and I want to welcome you to the second Science Series of the 1992-93 program. Tonight, we actually have, for the first time returning, a speaker who has previously given a Science Series. In fact, he gave the first one. And Jerry, we got more people this time. Is that right, than you had the first time? Yeah. The program has become a little more popular since 1990, when he gave our first Science Series. Our speaker tonight is Professor Jerre Johnson from the College of William & Mary. He's a geology professor there. He's been there since the dinosaurs roamed the earth, in other words, about 27 years. He has a PhD in geology from Indiana University, where he studied paleontology and stratigraphy. He is probably the expert on the geology of the Peninsula area. And he has helping him tonight 3 undergraduates from William & Mary. Yvonne Wall, who's a junior history and geology major, Angela Canal, who's a junior geology and English major, and Patricia Autry, who's a senior geology and economics major. That goes to show you that you can combine sciences and the humanities quite effectively and actually have fun and make a good career at it too. I want you to join me in welcoming Jerre Johnson and his William & Mary student assistants to tell us about the buffalo wallows on the peninsula.
Okay, hands. I want to see the hands of people who have seen the buffalo wallows on the peninsula. 3, 4, oh, fantastic. 5. Oh, now they're starting to lie more of them, right? Okay, that reminds me of the political campaigns. Now, what we're going to do is actually talk about something that many of you have seen, but you may not have seen it. You got that? You went past it, but you didn't see it. Now, it turns out that when you go around this area, how many have ever been on Fort Eustis Boulevard? Fort Eustis Boulevard. I didn't say Fort Useless, as some people do. Now, Fort Eustis Boulevard is an area where you can see these from the roadside. And you've driven along there, and what these little features look like are camera slide. What are they? Buffalo wallows. Okay, do we have our slide? No, wallow. Are you wallowing in ignorance back there? Now, what did I do with that? Yes, what did I do with it?
Ask them how they can hear in the back.
Huh? Okay, well, I can get it back there. Now, what a buffalo wallow is that thing right there. It looks like a pond. There it is. See, it's a pond. Everybody knows it's a pond. It's a depression. You know, it's a hole in the ground. You know what a hole in the ground is, right?
Yeah.
Yeah. And you see that young lady there, so you can see how big they are, right? Okay. Now, you really didn't want to learn about buffalo wallows, did you?
Yes, we did.
Oh. Hey, now, if we start to look at buffalo wallows, there's one. In the next slide, which we'll show you here, if you go along Fort Eustis Boulevard in the Chessie line, there's one, there's another, there's another, there's another. There are hundreds. There are thousands of them here. Watch that shape, old man, because I'm going to ask you about that shape in a minute. Got it? Okay? Look at that shape. What shape is that? Irregular. Okay. Now, if you go up 17, there's Fort Eustis Boulevard. Look at all those little blue splotches all over the place. A whole bunch of marshes and swamps over here. They're all over the place. These are little depressions that are as big as this room, to smaller than this room, to bigger than this room. Okay? Now, oh dear. Well, what do you want to know about them? They're just holes in the ground, aren't they? Aren't they? Well, what do you mean they're not? If you go down in Southside Virginia, you see little holes in the ground like that, and that, and that, and that. All over the place, they're down in Southside Virginia. They're all the way to Richmond, and they're almost to the sea. Okay, what are they? They're buffalo wallows. You know what a buffalo wallow is? Ah, they're a pond, aren't they? But how did they get to be buffalo wallows? Everybody knows that a while back, in this area, we had buffaloes. And the buffaloes would come along. They would find a little moist area right after the rain. There'd be a little pool of water, and they'd get down and they'd roll in it, and they'd pick up all that dirt, right? And then they'd walk over here off the countryside, and as the rain would wash off the dirt and the dirt would crumble off, they made the hole bigger by hauling away the dirt, right? A great idea. So now we know how the buffalo wallows got here. Any questions? How deep are they? Oh, when I measured one the other day, the pond was about 42 inches deep. And seemed about 30 degrees warm. What'd you hold your hand up for?
I beg to differ. I don't think that.
Ask her why. Why? Aha! There's an obnoxious one in the crowd. There's always some old biddy who speaks up and argues with you. Yes. Okay, Yvonne.
One thing, there wasn't a substantial number of buffalo in this area. So how can we have buffalo wallows?
Ah! That's not nice. You know that's not nice. You don't disagree with your teacher, right? Wrong. Oh, yeah, you do. You know, she's got a good point. There aren't many buffaloes around, and there haven't been buffaloes around at any time that we know of, so it doesn't seem like these could be formed by buffaloes. Maybe they're not buffalo. Yes?
Plus, buffaloes are all about the same size, especially the size of the Richmond size.
Well, but we just had more buffaloes. In one pond. It was a favorite place. You know, they went to Hot Springs, and some went to Washington. Different places. Okay. Now, okay, so you don't like that. Well, I have to admit to you, I'm lying to you. They're not buffalo wallows. They're meteorite impact craters.
Yes.
Yeah. Man, a few thousand years ago, meteorites just hit this place right and left and just pelted the place with a bunch of meteors. Okay? That's a good explanation. That's why there are all these little splotches around. Ah, you don't seem to be agreeing with me. Well, to be honest with you, it turns out that we looked around for the meteors, and there are no meteorites. We took magnetometers to find out whether there were meteors there. There were none. Bummer. Yes, it's called a bummer. It's bad news. It must be something else. Ah, Carolina Bays. Ah, be still. He's not supposed to do that so soon. Now, here we go. Carolina Bays, everybody knows there's over 100,000 of these things on the coastal plain. 100,000 of these things called Carolina Bays. What they are is an elliptical basin, see it? Rimmed with sand and having an axis, just like that. See it? There's another one, and there's another one. And there are 100,000 of these. This is on the eastern shore. There's some down in southeastern Virginia. And there are hundreds of them in the Carolinas. And the reason they call them Carolina Bays is bay trees grow in them. The sweet bay grows in them. So they're called Carolina Bays. Now, since all the rest of them are scattered all over the countryside, all the way from Richmond and Midlothian, all the way to the sea, these are Carolina Bays. A simple explanation. Why are you guys? Don't look at them. Look at me. I'm the one telling you the good story. Okay, come on, Tricia.
They're not oriented at all.
And they are not rimmed with sand.
They have the audacity to, were those basins that we looked at in the beginning, were they elliptical, smooth ellipses? I didn't hear him. Are they sand rimmed? No.
They're not oriented.
And they're not oriented. Oh, dang. Oh, I know what it is. Ah, there's the answer. This is called Plumtree Island, and there are a whole bunch of round basins in there. A whole bunch of them. Now, how did this happen? Well, this is also known as the Plumtree Island bombing range. And all of these...
I don't even know how to respond to that one.
Yeah? Well, actually, if you start to look at this very carefully, there are a whole bunch of these in here, and they bombed this island for years, but they only bombed a little island, and they only made a few of them. Turns out that bombing doesn't sound like a good idea. Maybe it's something else. Got it? Something else. But what could it be? What could it be? What could it be? Well, what do you think it might be?
Maybe somebody's taking a lot of bullets from the ground.
Oh, those were Civil War foxholes. Oh, American Revolutionary War foxholes. Okay, let's go try to find someplace else that we can look for to see if we can answer this important question. Because in the end, there's going to be a little surprise. Ready? If you go from Hampton, Seabath, where we are, and you go west, you go across a flat, up a rise, across a flat, up a rise, across a flat, and what does that landscape look like? Stairs. Yes, it turns out that the landscape in our area is stair-stepped. Now, what this means is that old place right there was once... the edge of a sea. So what do we call it? Yeah, you jump up and down there, and what do you say? Son of a beach, son of a beach. Yes? Yeah. And lo and behold, look, there's an old beach. Turns out that that's the old beach of the Chesapeake Bay. If some of you read recently about borings at Bruton Parish Church, okay, there are 12 boreholes. Now, guess who's got not many brains but a lot of muscle standing up here? I drilled 12 holes to find this great big vault underground that wasn't there. And what I did was I drilled 13.5 feet through Chesapeake Bay sediments into a bunch of garbage underneath, but never found a great vault with all the secrets for peace. The people who did disagree with me a bit were very, very kind, though, and in the end, they sent me a Herkimer diamond. Ah, yes, pretty, eh? Yeah. Now, when we start looking below the ground surface, we discover something, and that is, oh, by the way, anybody know where this is? Seabath. That's right. That's the hole that they dug in this great big ellipse around here, and what they found below the ground surface might answer our question. But when we look at Seabath, we've got a problem, because mainly what we see are sands and muds. And muds and sands don't do anything. You can pour acids on them, just about anything you can think of to destroy them, and nothing happens. So is that going to be our solution? No. However, see those sands? They're all over. Now remember, if you pour a gallon of water on top of a sand, what's going to happen to that gallon of water? It's going to soak in. Now you keep that in mind, will you? You got that? Yes. Yes, sir.
Sometimes if it's like a tall mountain,
Yeah?
it might come kind of flat on one side.
Yeah. In this case, this is a sand pit. This is called the Hampton Sanitary Landfill. For some of you who want to know where it is, it's an exciting place because not far from this site there are 7 and 8 foot diameter cypress trees that are 200,000 years old. That's on one of our field trips. In fact, I think we're running a field trip in a week or so to this pit. So there are just all kinds of marvelous things in here, okay? But let's go one step deeper, because that isn't going to do it. What does do it, though, is something underneath the sand like that. Those little white things. Now, shout out an answer for me. What are they? Shells. You got it. Good show. All those little white things are shells. Now, it turns out that some of those shells are like this. Here, old man, you answered that question. You get the shell. Okay? Now, so we've got shells. Got the shells? Okay, now, of what is a shell composed? Lime. It's calcium carbonate. It's lime. Good show. Hey, the kid even knew it. She'd better. She's taking paleontology. Now, okay, good. What's your water going to do? Acid rain. Oh, she's cheating on me up there. She said acid rain. What does that mean? It means that the water that's coming out of the atmosphere is an acid, right? Okay, if it's an acid and it comes to the soil where there's a lot of organic material, plants and rotting things, animals, that sort of thing, what's going to happen to the shell below? It's going to dissolve. Now, what I want to show you too is something else that we observed. Remember that we said, oh boy, CBAF will never let me back with all this in there. What we did was we went to the various stair steps and we measured the depth of these depressions. Okay? So we measured how deep they were. On the ones that were only 100,000 years or 120,000 years old, there was only about 2 feet, or about 2/3 of a meter deep or depth in each one of those. They're little shallow things, right? When we went to the ones that were about 200,000, a little about 204,000 years old, we discovered that they were more than 4.5 feet deep on the average. What's happening as the land gets older and older? They get deeper and deeper. If they get deeper and deeper, there must be something about the old land surfaces that get older and older that tell us something about its history, huh?
But what?
But what? Oh dear, there's always somebody like you around. Doggone it. Well, it just turns out that we got another part of our story here, yeah? Okay. Gee, I wonder how this is going to work. What did we say we had? You want to plug that back in? Beth, what do we have? We've got lime down below and sands above. We've got water coming in, and the water dissolves the shells and the lime. So now what's going to happen?
It's gonna go down.
Oh, what? What's going to go down? The sand above it. Okay, this is what the shell beds look like. See them? Now, there you go. What happens is the blue is lime. The yellow is sand. When water comes down through the sand, it hits the shell. And first, it's flat. Then it gets a little bit down, then more down, and more shell is dissolved. And before long, what do we have at the top? A depression. Now, every now and then, well, I once had a neighbor whose name was Reverend Pillow. He was kind of a little bit of a conservative minister. He had gone out for a revival one evening in early February, bitter cold night, rainy, nasty. When he came home, he got out of his car, started toward his house, and lo and behold, in front of his house, he suddenly had a big hole. He said, "Jerry, I thought the gates of hell had opened for me." Well, that really hadn't happened. What had happened, of course, was that the lime down here dissolved, made a hole, the hole got bigger, and finally, the roof fell in. Now, that's why you have caves over in western Virginia, but here you don't have, because over in western Virginia, you've got a roof rock. Here you don't. You need 4 things for caves. Ready? Number 1, water. Number 2, a rock or sediment that you can dissolve. Limestone. That's right, or shell beds. Number 3, you have to have some place for the water to drain away. Otherwise, the water is just going to dissolve and just sit there. No more dissolving is going to take place. So you've got to have some place to drain it, like the James River, or in Kentucky, from Mammoth Cave, the Green River. And the 4th thing you got to have a cave is a a roof rock. That's right. Now down here, we don't normally have a roof rock, so all of ours are just these gentle subsiding things. Now, how are we doing? We got buffalo wallows. We now know that they're really called sinkholes. Oh dear, sinkholes. Got that?
No.
Yes, sinkholes.
Yeah.
They're called sinkholes. We're going to convince you they're going to be called sinkholes because now if I call them buffalo wallows anymore, okay, I give you a penny each time I do that. Okay, good. Now, it turns out that a bunch of students, now these students turned out to be high school students, college students, undergraduates, no graduate students, no PhDs and all those kinds of people, but students. Went out there, and what they did was they went to the middle of one of these and they bored down in it with an auger. You know what an auger is? Here, old man, that's an auger. You can drill a hole into the earth with this, about as deep as you can lift it, and then after that you stop. What they discovered was something rather unusual in the middle of these. They found out that the layers they encountered were alternatingly light and dark. At the very top, in the middle of the sinkhole, it was dark-colored soil. As they went down, it became lighter gray soil. Then they got darker gray again, lighter gray, darker gray, and then lighter gray downward. Okay, now you've got a problem. What does that mean? You got any suggestions? How does a sinkhole fill up, by the way? Any suggestions? Oh, okay, rainwater falling on the ground and washing the ground into it. Doesn't that make sense? Which way does water flow? Old man? Downhill. Yeah, oh, sharp. And if there's a high ground here and a sinkhole in between, where is the water going to go? It's going to go in there. And when it goes in there, it's going to take dirt with it. We call that dirt sediment. Got that? Okay, we got sediment. Now, what else could go into the sinkhole? Oh boy, did you hear that? Boy, oh boy, she's been primed. Aeolian deposits. What does that mean?
When the wind blows.
Oh, when the wind blows. Well, that's what I'm doing. I don't see much aeolian deposit. Okay, now it turns out that dust does fall into these depressions. Dust falls into the depressions, and when it falls into the depressions, it fills up the depression a little bit, right? But all the time, what's happening underground? The lime is dissolving underground, so it keeps sinking and keeps sinking. And for the most part, this is a very slow process. Now, give me a clue, old man. What else? Don't look around. This old man right here. Now, what else could do this? I'm going to leave it to you and so you can branch out with a few answers. Well, I got you up a tree now, don't I? Any clues over here? I'm going to leave it to you. I'm going to branch out. I got him up. Good man, good man. Trees, yeah. Trees rain leaves down. And so what else is going to be found in the sinkhole? Leaves. But you know what we expected to find when we drilled into the sinkhole? Everything to be alike. It wasn't. Yes. What's up? Oh, did it fall off? Oh, dear. Thank you for telling me that, old man. Now, we're back in business. Okay, these things are really tough to have, aren't they? Now, ready? Look at something else. The student said, A, it's light and dark. It's light and dark. What can make that difference? So they took all the samples. See all the dots? 70 of these samples. They went and weighed after they dried it. They put it in a furnace and burned off all the carbon or organic matter, the plant material. And then they plotted how much plant material there was in each of these samples. And what they got was this curve, up and down. Ready? Now there's a buffalo wallow filled with, I owe you a penny. There's a sinkhole filled with this dark and light stuff. Oh, I know what it is. It took 3 years to fill it, didn't it? There's last autumn, there's the winter, there's the autumn before, fall, there's winter, and so forth, right? How much stuff, you think that much stuff is going to fall in a pond or in one of these sinkholes in a year?
No.
Do you think it might be 1,000 years or maybe 10,000 years? Ah, that's a possibility. Hey, if that's true, what could each one of these represent?
Could represent glacial and interglacial periods.
Aha, did you hear that? She said that, oh, hey, look, there is a cool period when there's not much vegetation. There's a warm period when there's a lot of vegetation falling in. There's a cooler period. There's a warmer period. And we got the solution. This pond existed for tens of thousands of years and collected sediment very slowly, and it recorded the warm periods and the cold periods. So what we learned from that is this. Look at that baby. Whoops. Look at it, upside down world. Now, look, we got a warm and a cold, a warm and a cold, warm and a cold, okay? Great, fantastic. Now we've solved our problems.
Which one is cold and which one is warm, though? Which one is light gray and which one is dark gray?
The light gray is cold and the dark gray is warm. Everybody knows that, right? She is being obnoxious again. She is being obnoxious. What are you suggesting? Loudly?
I want to change it around.
Huh?
Yes.
They say it's the other way around. That this is the cold and that's the warm. This is warm, cold, warm, cold, warm. Now look guys, now I don't like this disagreement, so let's just solve it all now. Who will vote for that hypothesis? Hold up your right hand. Anybody who doesn't vote owes me a dinner at the Williamsburg Inn. I'm going to watch, and if I don't see your hand go up. Okay, that's one hypothesis. Ready? Now, the obnoxious lady over there is suggesting that this is the case. Okay, who will vote for this hypothesis? Remember, when you do, you have to justify it. You can't just vote just because she's pretty and I'm ugly. Okay, let's go back and start this voting over again. Those who vote with me, please hold up your right hand. Gutless. Now, those who vote for the charming, beautiful young ladies. This isn't supposed to be the way it is. You're supposed to vote with me. I'm the professor. They're the... Okay, I'll tell you what. If that's the case, they're going to have to justify their... What's your question?
No, I think I got it.
You do?
I do.
What's your suggestion? As long as it agrees with me.
Well, I think it corroborates what they say, because if it's warmer, then there's obviously more vegetation and more stuff that would be creating the sediment, which I think are the dots. And then...
She's supporting me. More trees, warm weather, more trees, more vegetation. All right, babes, that's all right. I like that. Now that supports me. All right, you're good. She's sharp. What's this? Okay, come on. Let's disagree. Come on.
I don't think I can.
Yes, our grade is due tomorrow.
Oh.
Yes, Tricia?
I don't think that's true, because when you have cold periods and you have
Use
all
that
that
phone.
organic matter, it's not working.
Okay, it's not working. Okay.
But you put stuff in your refrigerator because it's cold,
Right.
and therefore it won't go bad and it won't disintegrate.
Hang on.
But
When
if
it's
you
warm.
keep it outside, then it disintegrates and rots. So if you have cold weather,
then it's more likely that you'd have more organic matter preserved.
Yes.
And if
yes.
it's really hot.
Don't you clap like that. That's unfair. Now, what you're trying to tell me is that if it's warm, all of the vegetation that's falling to the floor is going to rot in a hurry because there's a lot of organisms around there eating it up. Snails and all those sorts of things that go through, bacteria. And when it's warm, that happens faster. They're trying to tell me that when it's cool, that process, the animals that are cold-blooded aren't going to get out and do much, are they? Because it's too cold to do that. So they're going to stay inside, and they're not going to break it down very fast. And so the organic material is going to accumulate. Yes?
But we're living now at this end, and we know that we're in a warm era.
Oh. Bless your heart. I love you. Yeah, everybody knows that we're living in the young top. Right here is the bottom of the pond, and it's organic rich, and we're living in a warm period, and therefore it has to be warm. Oh, you're dear. I love you. I love you. Oh, super. I mean, we have now solved our problem, guys. Oh, wonderful. Okay, Tricia, let's try another attack. Boy, I'll tell you, I'll remember this tomorrow. Go ahead. Okay. Okay, speak up. Just turn around and speak up.
When you have a warm period, you have higher metabolic rates and higher levels of oxidation, so all of your organic matter is going to decay. When you have cold weather, cold climates, ice, organic matter is preserved.
Whoa, yeah, but we're just saying, look up there. This is where the problem falls down. This is why you and I have a problem.
I don't have the problem.
Oh, I've heard that before. This is sounding more and more like a political debate. Now, what it is there's a real dilemma here. Yes, question.
Yeah, we can't hear anything back here.
Okay, what she's saying is, oh, it's cool. Here, it's going to preserve the vegetation. It's warm here, the vegetation is going to rot away in a hurry or be eaten up.
Don't be sarcastic.
Okay, now that's probably true, but there's something here that doesn't meet the eye, and she put her finger on it, and she's the one that kept me in this terrible state of not knowing for years, because it should be that that's the warm period that we're living in, therefore high organic matter should be warm. However, it turns out too that these are what? They're ponds, aren't they? Are they ponds? Are they ponds back there? Yes, they're ponds. Now, are the ponds there all year long now? No, they come in February and they dry up in July and August and September, in most cases except for this year. Okay? This is the first year they've stayed wet all year long. Why is it staying wet all year long this year, not last year? Oh, there's more rain this year. And what else about this summer? Cooler, right? Okay. Now, if you're in a glacial period, is it going to be warmer or cooler during the summer? Cooler. If it's going to be cooler during the summer, the ponds are going to be longer lasting, aren't they? What's going to happen in winter to those ponds? They're going to freeze over, and Jiminy frost, they don't disappear at all. So any leaf that falls in there is just going to stay there. It's not going to rot away. Oh, darn, but that still doesn't solve that problem up there, does it? That's the problem we didn't discuss yet. You guys are a little bit obnoxious. You know what that means? You're disagreeable. Because you see, we've got to decide which is really true, that one or that one. So how are we going to do it? Voting doesn't work. Voting, you don't vote in science. You look at the evidence. So what are we going to do? Did you hear that? Huh? Ask a scientist. I did. When I was in Utrecht last year, I went and took samples from here, from there, from there, and from down here. Where? Utrecht in the Netherlands. It's in the Netherlands, not in Holland. In the Netherlands. Now, what they told me was this. If this would have been a warm period, we would have found magnolia and all those warm climate plants, right? If this was a cold period here, what would we expect to find? Come on, spruce up a little bit. Spruce. Okay, go a fir piece away. Fir. So you get spruce and fir. Now, where do spruce and fir live? They live up in southern Canada, don't they? Is that warmer or colder? Colder. Aha! And when they brought these in to me, guess what? That had spruce and fir in it. The cold climate. This had warm climate things. This was between the glacials. This was during a glacial period, and this was between one that was a glacial. And I was wrong. Oh, but I had argued so much for my opinion. The thing is that you can't go on opinion. You have to go look at the evidence. And when they brought the evidence in, they found out that this is the glacial, the period of glaciation. This is here. Now, look at that curve. You guys are living on the peninsula. That is the longest, most continuous pollen record known from North America. Right here. In the terrestrial or land environment. That's the longest pollen record, the most continuous one. And therefore it tells us the most about climate. All because some stupid little students got down in the bottom of a depression and put an auger down. Now, those students really were, one, curious. That's really wonderful. If you'd been out there arguing with them, you would have been impressed by the fact that they didn't give up easily. They kept digging, because when you pull that mud up out of there, and they were covered with mud dripping off their eyes and their ears and everything, because when they turned the auger upside down, guess where all the dirt ran? Onto them. And they were a miserable looking lot. I didn't even want them to ride in the same vehicle with me, except for they said I was dirtier. So the point is that these kids were curious. They worked hard. They kept after it. You adults know that's called persistence. And those are good qualities. Now, it turns out that there are other stories that are coming out of this, and you'll read about those in the scientific literature when you get to be a day or two older. Okay? Now, it turns out, though, that when these buffalo wallows were forming, there were things like this around. Okay, now let me tell you about this. There was a black gentleman who was walking through one of the creeks not far from here. He looked down and he found a piece of wood. He saw a piece of wood. So that black gentleman, in his wisdom, in his curiosity, bent over, and what he found was this piece of wood. When he picked it out, it turned out not to be a piece of wood, but in fact a tooth. A tooth. Okay? Now, he looked around. And found this. Then, he kept looking, and he found this. Ah, another bone. Okay, a joint of some sort. Now, this gentleman, no reflection on the people at NASA, but this gentleman took this thing, which is a tooth, down to NASA. They didn't identify it for him because they have no paleontologist. No reflection on them. They went over to a couple of other places that I won't mention because they should have known better. Finally, one day, he ended up on my doorstep with all of these pieces. And you know what I said? He had him laying out on the edge of a table, and I says, oh my gosh, only stronger than that. It's a mastodon. It's a mastodon. It's a fossil elephant. It's a fossil elephant. This is a fossil elephant. Yeah.
If that graph, if I understand what that graph says, then we're supposed to be in a glacial period.
Oh no, there's another problem we've got to tell you about at a later date. There's a reason there's more organic present today than there is in the older record, okay? And that's a long story. When you get in my freshman class at William and Mary, I'll continue the story, because there's 2 or 3 more chapters. Got it? Yeah, you're right. You keep asking that nasty question, and I'll keep throwing this tooth at you. Okay? No, you don't get the tooth. You don't get the tooth. Okay, now, hang on just a second here, and then I'll answer your questions, okay? It turns out that when you look at a mastodon tooth, its upper surface should have a bunch of bumps on it, like this. Where are the bumps? They're gone. Why would they be gone? Huh? No, not the acid rain. What do you think?
They might have rotted off.
They might have rotted off, but what else do you do? What happens to you? What's the difference between his teeth and my teeth? My teeth are old. What happens to old teeth? They get worn down. So this poor old tooth got worn down. Now what happens when you, yes?
It falls out.
It could fall out, but a lot of teeth don't fall out right away, do they?
They had to get it like chopped off or like knocked off.
Okay, now, in this case, it wore down. It wore down. When you wear out the outside of your teeth, what happens to the inside? It decays. Okay, there's the small decay hole in its tooth, right there. See it? That's a cavity. That's bigger than your teeth, young man. Now, the funny thing about this is, this tooth set in this jaw. Got it? You see that? Okay. Now, if a cavity develops or forms at the top, where does it go? It goes downward, and there's a hole at the bottom called the opening for the cavity. And if it's sitting in a jaw, what's it going to do to the inside of the jaw? It's going to make a hole. If it makes a hole inside the jaw, what's it going to do on the outside? It's going to make a hole. This was not a happy camper. This poor elephant was in pain. Every time it bit down on some leaves, it was Ouchville. It was not a very happy day. So what we have here is an elephant that may have walked across one of those buffalo wallows. Now, ready? Here's some other pieces. Now you guys got to tell me what these are. I don't want you to pull my leg any. What? They are. They're joints. Yes, they're joints. They're parts of the foot. This elephant walked on its fingernails or its fingertips, and it would walk around. And here are the bones in the feet that the animal walked on. Now, this gentleman who showed me these bones took me out and said, hey, I'll show you where it came from. Oh, I loved him. This was early February. He forgot to tell me one minor thing about the site, and that is, it was underwater. And so I said, okay, I'll come back next week. So I came back next week with my wetsuit, and lo and behold, this man, in his wisdom, with a 4th grade education, said, if you want to find these bones, don't look where I found them, but go up the stream to about this point and look there. This guy was smart. He was persistent. Persistent because he had to go all over the countryside to find out what the stupid thing was. Most of us would have put it on our shelf and forgotten about it. This guy went all over the countryside. He was curious. Well, you know what? He was wrong. I took my ice pick and I probed for an hour where he told me to. Well, I moved over about a yard and poked again, and there's the marks that I made on the foot bones that were all in place with my ice pick. He was off by this far along this stream. This guy was sharp.
How do you know where to go?
Well, he looked at the stream channel, and the stream was making a great big meander, a big curve. And so what he figured out was if the bones were a little bit downstream, the curving water would have washed them out here and carried them over here. So he went upstream to where the water hit the edge of the bank the hardest and said, there it is. And he did. He was sharp. Now, I think that really tells us something about how to be a scientist, a person who seeks after information about the world, whether it be a physicist or a chemist or whatever. You need to be curious. You need to be persistent. You need to be logical. Don't vote on things. Look for facts. Thank you. Yeah. Huh? Yeah, we'll get, yeah, why don't you give them out, the other two. Okay, does someone have a question? Who would like a Chesapeake Jeffersonius? Oh, you know the shells she's handing out, the shells that are being handed out, are found abundantly along our rivers and tidewater. It's called Chesapeake Jeffersonius. It's named after the Chesapeake Bay, and pecten means scallop. Okay? Now, Jefferson, it's named after Jefferson. It's such a beautiful clam or scallop that we want to make it the state fossil. So if you want to write to your state legislators and say, hey, make Chesapeake Jeffersonius the state fossil, feel free to. Okay. They're extinct. They died out about 4 million years ago. They lived for only about 500,000 years, but they form, some of them are magnificent clams, or scallops, I should call them. They're really beautiful. What they're doing now is taking one of these cores that we took, and they're stripping it apart. And as you might gather, this is the kind of evidence we use to get our story out of the ground. You guys got that all undone? Hey, there you go, Angela. Okay, seriously, questions. I'll answer any questions that you might have. Yes, sir.